Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 46, Liquids and Solids, Part 1. We are in Chapter 10 of your textbook. Here are our objectives for today's video. Pause here. This entire chapter is on intermolecular forces. Up until this point, we've mostly talked about intramolecular forces. Those are the forces that hold molecules together, effectively bonding, whereas intermolecular forces are forces that are between separate molecules. We've discussed hydrogen bonding here and there. You've probably also heard about it in biology. That's one example of an intermolecular force. Intermolecular forces, those are what hold molecules to one another, not in the molecule. That would be an intramolecular force. So whenever you need to separate the molecules, say when you're going from a liquid to a solid, you're going to need to add energy. Pause here. A rough sketch of the picture is completely fine. So the first type of intermolecular force that we are going to discuss is a dipole-dipole interaction. So that is when you have a polar molecule that interacts with another polar molecule. Just as a reminder, those little delta symbols, that just means a partial charge. So for example, that molecule that's listed there, that could be, say, HCl, because we would have the H that had a partial positive and the Cl that had a partial negative. So when you have these dipoles near each other, there will be an attractive force that is called a dipole-dipole interaction. In order to have a dipole-dipole interaction, you must have a polar molecule. Pause here. All right, I'm going to wait like 5 or so seconds, and then I will say the answers out loud. NaCl cannot. That is not a polar molecule. That is an ionic bond. We'll talk more about that later in this video. B, that actually cannot. Even though the CF bond is polar, CF4 is a completely symmetric molecule, so the molecule is nonpolar. CF2H2, that has an asymmetric placement of polar bonds. That's also tetrahedral, but two of those are the nonpolar bonds. And then C2H6, this cannot. The CH bond is considered to be totally nonpolar, so that cannot have a dipole-dipole interaction. Pause here, you don't really need the pictures. Right, so hydrogen bonding is just a subset of dipole-dipole interactions. So an extremely strong dipole-dipole interaction specifically that occurs when hydrogen bonds with one of the three most electronegative elements, which would be oxygen, fluorine, or nitrogen. So whenever hydrogen is directly bonded to oxygen, fluorine, or nitrogen, that means that something can hydrogen bond, which usually means that it has a pretty high boiling point compared to similar molecules. So just a note, this doesn't pop up a whole lot, but the hydrogen actually has to be directly connected to that oxygen or that nitrogen or that fluorine. Just because a molecule has both of those elements does not necessarily mean that it can hydrogen bond. Pause here, you don't really need the picture. And then the third type of intermolecular force for this video is London dispersion forces. So this occurs with anything that has electrons, pretty much, but it is most important for things that we typically consider to be nonpolar, like hydrocarbons. They could actually form what's called a temporary dipole. So what ends up happening is you've got some random, or not exactly random, but motion of electrons all around a molecule. And then for a fraction of a second, slightly more of those electrons are on one part of a molecule than another. That portion of the molecule has a partial negative charge. The other portion has a partial positive charge. It can induce that in another atom or molecule. And then we've got these temporary attractions. They are fairly weak compared to comparable dipole-dipole or hydrogen bonding. But when you have really, really big molecules like diamond, the London dispersion forces can be very, very strong. Pause here, you don't really need the picture. And then the fourth type of intermolecular force is ionic bonding. I put bonding in quotes because my personal viewpoint on this, or not really personal, my professional viewpoint on this, is that bonding is really only when we have constructive interference of orbitals, and we don't have that with ionic bonding. It's really just a very strong intermolecular force that occurs between charges. So we've got in this example Na plus and Cl minus, and then it's held in this crystal lattice by these extremely strong intermolecular forces. Ionic solids tend to have super, super high melting points for this reason. Pause here. And I'll wait about 5 seconds and then I will say the answer out loud. All right, HF, it has electrons, therefore it can have LDFs. And then you could either say dipole-dipole or hydrogen bonding. Since hydrogen bonding is a subset of dipole-dipole, you don't really have to say both. So I would say London dispersion force, hydrogen bonding. HCl, it has electrons, therefore London dispersion force. And then the HCl bond is polar, so dipole-dipole. NaCl, you could say London dispersion force, but you really don't need to for ionic things. But if you did, you wouldn't be wrong. But most importantly, ionic bonding. CH2Cl2, it has London dispersion forces because it has electrons, and it has dipole-dipole forces since this molecule is polar. And then last CH4, it just has London dispersion forces since it is completely nonpolar. Right, thank you so much for watching and have a great night.